All right. So this week, this is not really a monthly development cycle meeting. This is just a meeting for just discussing what are the potential options for the next monthly development cycle. If anyone is interested in algorithm, please bring it up, and we can take a look at the paper, and then we can all decide on what are the topics that we want to work on for the next monthly development cycle. So maybe we can go one by one, and we all maybe say an algorithm that we're interested in, and maybe in the end we can put up a vote or something like that. Does that sound good with everyone?
Yeah.
All right, sounds good.
It's gonna get political.
Yeah, and I would say, if we are committing to a monthly development cycle on a specific algorithm, the person who are using this algorithm should be, ideally using it for research, and should probably lead the discussion a little bit more. So that's just some consideration as well. All right. So last week we had some really good ideas. Rosalind, I think you mentioned Dreamer, and I remember Ali mentioned something about offline reinforcement learning. Maybe we can start with Rosalind. If you could tell us a little bit more about Dreamer.
Basically, it's similar to word models, I think. Wait, let me pull up my notes.
Yeah.
So what they do is, first it's mainly pixel-based, how do you call it? Pixel-based environments.
Mm-hmm.
And they are trying to address, like, for example, SAC not working well out of the box on those deep mind control tasks, I believe.
Okay.
So what they do is they build wait a second. Let me share the paper really quick.
Yeah.
Oh no, come on.
Is it mainly, I remember, like model-based reinforcement learning?
Yes, it's full model-based.
Mm-hmm. I see. Yep, you're good. We see the presentation.
Well, it's not really a presentation, but just a paper.
Yeah.
So as I said before, it's like they're mainly focused on the pixel-based tasks.
Mm-hmm.
And the idea here is usually in model-based reinforcement learning and planning, they use planning, right, to use the model. So they have to, you first learn something like an encoder to, reconstruct the observations, and the previous methods would plan on the reconstructed observation.
Mm-hmm.
But here they propose to directly work in the learned latent dynamics, so you don't need to reconstruct anymore. You just plan in the latent space, and that's actually where the name of the paper, Dreamer, comes from.
Okay.
So I think the core is pretty much summed up in this figure. Like at first you have to learn the dynamics, to have a good internal belief system.
Mm-hmm.
And from that they also learn all the other components directly from on top of the latent dynamics, namely the rewards. And what's personally interesting is that the actor is now working on the latent space. Here, for example, this action is directly outputted by taking the latent variable as an input observation, basically.
Mm-hmm.
And so that's for the dynamics. And then learning behavior in imagination, it's doing rollouts in the latent space,
Mm-hmm.
which, well, this is basically one of the main benefits of model-based reinforcement learning. And then what the agent learns in the dream, the latent space, it can then apply to the real world, basically.
I see. So it uses sort of the environment to almost the models to dream about more experiences, so it's more sample efficient.
Yes.
I see.
Well, also, besides sample efficiency, I guess there is a little bit more freedom to explore, in a sense.
Mm-hmm.
It's like the noise from the model kind of helps generalization, in a sense.
Mm-hmm.
It's more related to neuroscience and psychology, but they say that one function of the dreams is to improve generalization of the brain, the human brain.
Mm-hmm. I see.
Maybe that's the concept they have been leveraging here.
Mm-hmm. I see. Have you been able to find any maybe open source code on this project?
I believe the author open sourced the. Oh no.
By the way, is this a Dreamer V2 or a Dreamer V1?
V1.
Okay. I see.
I will paste the link in the Slack channel.
Mm-hmm.
The author is usually open sourcing all of his code anyway. So.
That's great to hear.
But it's TensorFlow, so.
Okay. So what about Dreamer 2? Is this something that is drastically different, or?
I think the idea is the same. They just adapted it to discrete action spaces.
Okay. I see.
Let me see if I still have the. Yes, it's basically Dreamer V1 for discrete action spaces tasks.
Mm-hmm. I see. Do you have the link to the Dreamer V2 paper by any chance?
Yes, just a second.
Okay, thank you. Thanks. Mm-hmm. Got it. Thanks. All right. So definitely a really good, interesting algorithm to as a candidate. Very interesting. Maybe we should jump on to the next potential algorithm. Ali, did you have something to suggest? I remember from last week about offline reinforcement learning.
Yeah, I can actually. I did a kind of a survey presentation on offline RL to my team a while ago. Let me see if I can just share that here.
Yeah, nice. That'll be great.
Yeah, this one. You guys see?
Yes.
Can you see mine? Okay, cool.
Yeah.
So this is a collection of. Oops, that's not it. Okay. This was a survey I did on a collection of different offline or batch RL papers.
Mm-hmm.
Kind of the motivation for this is how would you train an RL policy if you don't have access to a simulator, but you only have access to some offline data sets, so some already stored and logged data sets. So the goal is a little different, I guess, with offline RL compared to, RL that's trained on a policy, on a simulator, in that you have to kind of maximally exploit a given data set. You don't really have the option to explore new iterations or new episodes.
Mm-hmm.
It's a little different than imitation RL2 because although you do also imitation learning, you also learn from like a fixed data set. Typically, in imitation learning, you have access to an optimal policy, like a demonstrator that's doing something really, really good.
Mm-hmm.
Whereas in offline RL, you probably only have access to a collection of maybe randomly explored data, maybe suboptimally explored data, and so on.
Mm-hmm.
So here's kind of like a nice little video I found from the Google blog on offline RL. So typically we do this. We have a policy that's trained through an environment, whereas in offline RL, basically you have this environment generate a big data set first, and then you go ahead and train your policy from that. So here are some papers. They kind of talk about what the problem is. And the problem really always boils down to, because you don't have access to new exploration examples, you are always going to have some model bias and some uncertainty about how your policy will perform on those examples. And everything that has kind of come out for different algorithms is basically constraining how you do the updates. So, for example, this first one called BCQ is called batch constrained Q learning. You still run normal Q learning, but at the maximization step, where you would typically, maximize a new policy that gives you the highest next Q. Here, instead, you only maximize over actions that you've actually seen before in that data set. So that was BCQ. There's some comparisons of how it performs relative to other behavioral cloning algorithms or other just traditional algorithms just using the alpha data set. Mm-hmm. And then more recently, there's been other approaches. This one is called BEAR, Bootstrap Error Aggregation. And what they basically do is say, well, since we don't have this perfect Q estimate, what we're going to do is add this additional constraint, which is your new samples should come close to data set. So here, this is maximum mean discrepancy, which kind of enforces the support of your learned policy distribution to be similar to the observed distribution. And they have released some code for this, which does okay. I'll kind of skip and then just say this is a recent paper that came out. This is why I actually did the whole summary. Mm-hmm. And they actually said that if you look at the more state-of-the-art off-policy RL algorithms, so not offline or batch RL algorithms, just like 2D3 or C51 or so on, those actually perform pretty well if you have a good large data set. Mm-hmm. And then a lot of people have been looking at, okay, maybe I don't have a good large data set, but I can use generative modeling or some other mechanism to make my data set, augmentation technique, make my data set more diverse and more large. And they have this kind of cool technique called random ensemble mixtures, which says, well, let me train multiple Q heads and then do some ensembling over them to get a good, robust policy. Mm-hmm. And yeah, they get actually really good results here. So their offline REM, random ensemble model, does really well on these Atari environments where they have logged examples for, even compared to BCQ and BEAR from the past.
Mm-hmm.
And they also have some examples on Majoko environments.
Oh.
So yeah, I can probably share this, convert this into like a PDF or something and share it out. But yeah, I just surveyed a bunch of the papers. There's some new ones too that have come out the last couple of months. This was, I think, something I put together in July. So there's been quite a bit of work since then too. This area moves pretty fast, it seems.
Yeah, it would definitely appear so.
And yeah, there's like these new benchmark data sets that are mostly of Atari and Majoko. So that's worth looking at. I've been looking at some other environments that we've been using with my team, and our results are still a bit mixed. We usually find that for data sets that have a lot of randomness, maybe there's stochasticity in the states that you observe, even with the same initial state and same actions, you could observe very different outcomes.
Mm-hmm.
And many of the approaches really do really well. So we've tried to do things like adding memory or adding history to your state space that often improve. But anyway, that's RL in a nutshell, I guess.
Yeah, that's a very nice presentation. Thanks so much for brushing up our knowledge on this domain. I have a couple questions. So
Sure.
for these methods that is presented, do they have their source code available? And have you tried to implement it? Either using these source code or try to play around it, and if so, what was sort of your experience with them?
Yeah, great question. So some of these papers, especially the earlier ones like Bear and BCQ, there are official implementations available from, like, this one's from Bear. And there are also some unofficial examples that have been fun to look at. So yeah, I and some people on our team have looked at these and have been able to replicate some of the results, quite a few of them, and they're pretty good.
Mm-hmm.
There is kind of this recent push by two people, the Berkeley teams, so they have this data for RL evaluations. So I think it's this came out pretty recently. They're making this benchmark for evaluating different offline RL algorithms, as well as the DeepMind and Brain team has this DeepRL Unplugged technique. So they've released some new, I think it's this. They've released some new algorithms and some new data sets. And we've just started looking at them, so I haven't gone through this yet. But
I see. So there's definitely a lot of resources available, not only from the paper side, but from the source code side as well.
Yeah, this is growing quite a bit, so there's a lot of new implementations available. But the ones that I mentioned, most of them are available. I'm trying to find where they did the control suite example. Let's see, this might be the data set loading, yeah. Maybe this one. Oops. Yeah, so they're using Acme and they've done, so the random ensemble network I was talking about, they have implemented it and they have the code available.
I see. Yeah, the reason why I asked about are there open source code available was because sometimes implementation details really matters, and without source code, it's just not possible to know them.
Exactly. Yeah. It's here. Here's, I'm not sure why they're so separate, but the both their 51 and this other quantum network that they have compared to the last paper, they have released their implementation of it. But again, this one is in dopamine and TensorFlow, not in PyTorch. So
Yeah, that's fine. That's all fine.
yeah.
Very nice, very nice. All right. Definitely very interesting results. I know Sergey Levine. Sergey.
Sergey Levine. Yeah.
Yeah, he has been a huge advocate in the offline reinforcement learning, and he has done some great tutorials as well. So I've been quite interested in the domain as well. So definitely something very interesting. So for anyone, does anyone else have any sort of algorithms or papers they would like to potentially work on for the next monthly development cycle?
I don't have any other paper, but with regard to offline oral, I also heard about this conservative Q learning by the Sergey Levine team. Maybe we can. I just want to add up that. That's all. I can share the link. Yeah, that's all.
Nice. Thanks for sharing. I'll also post it in the Slack channel as well, real quick. Anyone else?
So yeah, I think there are also these papers regarding the curiosity, which might be interesting. Simple concepts and well described, well defined, and there's a lot of open source implementations.
Do you have a specific paper in mind?
For example, there's like curiosity-driven exploration. I think this is regarding the paper. Intrinsic motivation, intrinsic curiosity module. Oh, I think this is the. Let me search for it.
Is it ICM?
Yes, ICM. Yes. Yeah, the paper is called curiosity-driven exploration, and it's pretty much ICM.
I see.
I believe there is a more recent one.
There is distributed version. Yeah, there is distributed version of this paper, which is called how it's called.
Larger scale
large scale
study of curiosity.
Yes, exactly. So there's also distributed version of this paper, and these are simple ideas, simple paper, and something easy, to work with, definitely, compared to other papers, probably.
Nice. Do you guys mind sharing the sort of the distributed version, the newest version, on the chat?
And there is also random exploration, right, which is the same idea, but same idea of curiosity, but implementation-wise a little bit different. Called random network distillation.
I see.
Distillation.
So we go ahead.
It's called exploration by random network distillation. So I can post it. So these are all around the curiosity, pretty much.
I see. So for the random network distillation, one of the we actually have someone who contributed a PR to Cleaner Out repository, and Chan contributed a PPO with the random network distillation that has apparently worked pretty well in Montezuma Revenge. So I've loved to sort of revisit it since I never implemented myself. But in case anyone who is interested, here I'll link the code in the Slack channel real quick. But definitely some. I really enjoy the line of work of curiosity-driven learning as well.
Yeah. And regarding nice papers, I can also recommend this Go and Explore. It's called, I guess. It's a very interesting paper, very interesting idea with the external memory module.
The idea is interesting, but the realization is really hacky.
Yes, exactly. But it's kind of like idea is it's kind of like interesting. It's very hacky probably, but yeah, it's very hacky, definitely. But the results are amazing. The results they also
Yes, of course.
pretty impressive. So there is
I
something
believe
to it.
there is a 2 version as of now. There was the V1 where which is the one I was referring to when I said hacky, because they use the simulator reset feature to rewind the agents to interesting milestones from which it can explore, right? Instead of starting over every time. So that was the hack I was referring to, but they say in version 2 they introduce something that removes the need for such a feature. So maybe, well,
Yeah. There's. I think it's still hacky, even if this version 2.
really? Yeah, that's
I
too
think
bad.
so.
I believe it's the same paper, right? They have just updated the
Yeah,
the
there is
archive
a lot
link.
of a lot of hard-coded parts, kind of like make a lot of assumptions, and
Also the simulator code, which does not seem to be quite open sourced. Go explore, huh?
All right. Does anyone else have any idea?
I should have one next month because I just started a survey for meta learning. So
Nice. Not for the current month, but you said for next month?
for next month, yeah, I just started it.
I see.
I don't have any papers to suggest yet.
Yeah, that sounds great. Definitely let us know by the end of the month and when we decide the next monthly development cycle. I think meta learning has a lot of interesting things as well.
Okay.
All right. So I am going to create a poll in the Slack channel. And let's. Oh, right. Sorry. Let me briefly talk about what I was going to propose. I was just going to propose to work on sample factory. Is anyone not aware of the work by the sample factory by any chance?
No, that's not prepared.
Okay, I'll do a quick sort of not really a presentation, but just a sort of a quick demo of what sample factory is.
Okay.
So sample factory is sort of like Impala, but it's optimized for a single machines. So Impala, it uses dozens of servers to collect the rollouts information and use one single learner. But in practice, not everyone has a cluster to run. So in sample factory, what they do is to put everything CPU related on the CPU side. So the CPU worker always take the action and generate the rollouts from the environment. But they also have this policy workers and learner that are on the GPU side that are always generating actions. So they have very high throughput, significantly high throughput than methods such as Impala on a single machine. So over here, we see that Impala almost have, let's say 5 times as more throughput, or in some extreme cases, 14 times as many throughputs. So from the data generation perspective, it's just a really fast algorithm. So that is something that I think may be interesting to implement as well.
Quick question.
Yeah.
Is there any performance improvement related to the method?
Performance improvement, how? Like, can the agent learn better behaviors in the end?
Yes. Does it help the agent in some way or another? For example, when we add the distributed computing to a simpler algorithm such as DDPG, I believe you have this effect of improved performance due to more diversity in the sample. Oh yes, that's actually figure 4. They compare the performance you reach, but based on the time you need to reach it.
Yeah.
When using existing method.
So what appears to be... Go ahead.
I did not see any other performance-related gain. It's purely sample efficiency focused, the paper.
Yes. Well, the sample efficiency is actually relatively the same as CDRL.
It's more like wall clock performance, right?
Wall clock.
Yes, exactly. If you see the training time, it takes 1/6 of the training time. So which means it's a really fast algorithm.
Well, in the best case. And I guess also less compute, or maybe not less compute per se, but less machines.
Yeah, less machines.
Better utilization, definitely. The best utilization.
Roger that.
But the question is, because from what I look at the source code, and it's it's really difficult, So, do you think that's even possible to because obviously implementing all would be probably beyond the scope, I think, It's given that it's very difficult. So, how far, probably will be possible to maybe some pieces or something. Because, that was my impression, that it's actually very difficult to implement. And there's a lot of,
I see.
That was my...
So I think their code is, I think it can be simplified. Especially we had in an example, we had the Apex DQN implementation, which is sort of a less optimized version than what they do. And essentially we're able to implement this kind of a distributed algorithms still in a single file. You basically just have these number of actors, I have this thing called data processors, but basically I also have a learner. So you just run them and you keep most of the code the same and it's still able to run. So they're doing some very clever optimizations with the shared memory buffer, but I think overall the structure can be followed. So I think from implementation standpoint, it's probably not that difficult.
Okay.
All right. So maybe let's put it up to a vote. I will create a poll real quick. So this will be a sort of a multiple vote as well. So you can vote on multiple choices, algorithms for the next monthly dev. And the first choice is Dreamer, and then offline RL, and then curiosity, driven learning, and lastly sample factory. Okay. Let me see. Post it in a channel, send Polly. Are you guys able to see this? Yep, we can do, yeah. So you can vote all four if you want. If there's a tie, I'll just kind of decide. I guess there's no better way. I'll sort of, if that case happens. Now, do we have all the votes? Oh, last one, of
We need
course.
to recount the votes.
yeah, right. It's quite fitting for the current situation. All right.
It looks so uniform.
There is a fraud. There is a fraud going on.
Okay. Let's see.
Sample factory then.
All right. Okay. Sounds good. Let's do sample factory then. Yeah, I think I thought offline RL was going to get the win, but yeah, all sounds good to me.
I was voting for 2, but I don't know how it goes to 4. I mean, like, sorry.
Oh yeah. By all means, we can recount the vote. All right. Has everyone put in their response yet? Thanks so much for participating as well. By the way, Ali, did you vote for offline RL by any chance?
I voted for Dreamer and for Sample. I didn't want to vote for my own thing.
Okay. So we have a tie between offline RL and the sample factory. I have a quick question. So if we do offline RL, Ali, do you think maybe you can partially lead the discussion? I'll definitely help as well. But yeah, do you think maybe you can partially lead the discussion or the implementation as well?
Yeah, I'll be glad to push that direction. Sure, it'll be fun.
Yeah,
Some experience already. So.
Sounds great. All right, let's go with offline RL then. Maybe Simple Factory or Dreamer or Curiosity Driven Learning next time. All right. Sounds great. So let's talk maybe a little bit more about offline RL. So I noticed there's quite a bit of offline RL papers. So Ali, do you have any recommendation for a specific one that we should look into?
Yeah, I think the RL Unplugged paper, I'll put these links in here now, and the data sets for RL, they're good because they're good surveys on the field. People are mentioning, Sergey Levine has been really advocating. I'll put them in the Slack channel. I guess that's more persistent. Those are good ones. And then I really like the optimistic perspective paper on offline RL because after having us go through the distributional RL perspective paper, which was a good way of seeing how those algorithmic improvements actually do have a good impact on even offline settings. So maybe those 3 I think would be good ones, and I'll paste these links here.
Also, since maybe we're offline RL is something that we have never done before, Another thing that maybe we could do is to just sort of take it slow. Maybe we don't have to decide a specific offline RL algorithm for the monthly development cycle. We could maybe all of us could just read all of these papers, just get a feel of the field, and next week we decide on a specific offline RL algorithm that we're going to implement for the monthly dev.
That makes sense.
Yeah.
Okay, sounds great.
Yeah. Yes.
But I'll try to paste my slides here to try and figure out how to turn this into a PDF.
That'll be fantastic.
So this offline RL, how much? I mean, like in terms of GPU or CPU, does it take more memory or huge processing power, or just in a nominal computer you can run this? You have any idea?
I can give a kind of high-level answer. I think it does depend on what type of data set you're trying to train the offline RL policy on. The most interesting results and most interesting papers have been trained on very large collections of Atari data set. So for that, like all the things they do for featurizing the images into representations they can then train on does require, I think, GPUs, but you don't need like a big cluster to make things faster if you want to use the whole data set. But getting started, I think, with this on a different data set or non-pixel-based environments shouldn't require big compute infrastructure.
Okay, fine.
Yeah, that's interesting because I feel like if you're doing offline RL, it in a way the throughput should be higher because you're just loading things from the datasets and then you can just put everything on the GPU side and do very fast updates.
That's true, yeah. But I guess typically the datasets that have been released are fairly large. So if you want to go through all of them, people have found that distributing the featurization part, the transforming those into representation that then get fed into the policy update, helps speeding up training. But yeah, I think there's a little bit of trade-off there.
I see. And out of curiosity, for these methods, you said the training data set is pretty large. What what magnitude are we expecting? Is it like a gigabytes or tens of gigabytes?
Yeah, I think the latest ones released by the Google DeepMind's team are on the tens of gigabytes, close to 100 maybe, but it's not terabytes. But
Okay.
that's because they have basically, I think, let me see if I find the actual paper, but I think it's 10 million frames per environment.
I see. Maybe even for our case, we don't even have to, we can just start with one environment. So that case, we may not use the entirety of the data set.
Makes sense, yeah.
All right, sounds good. So for the next step, I guess, is that before the next weekly meeting, everyone should read a little bit about offline RL papers, and afterwards we'll meet in the weekly meeting. We'll just talk about what you find interesting in these papers, and maybe we can decide on the final algorithm. That sounds good to everyone?
Yeah, perfect.
Yes.
Yeah.
Fantastic. I feel very excited because I've been interested in offline RL as well. Thanks so much, Ali, for bringing up all these helpful resources.
My pleasure, yeah.
All right. If anyone doesn't have any last comments, I would actually. I will be okay if we terminate the meeting a little early because I got a meeting to run at 6 as well. So does anyone have sort of last minute questions or comments? We still have 10 minutes. All right. Sounds good. Thanks everyone for coming, and I really enjoyed doing poll this time. Thanks everyone for pitching in, and read the papers, and we'll see you guys next week.
Yeah, see you.
Thanks.
Thank you. Yeah, thank you. Bye.
Thank you.
Bye.
Bye.
Bye. Yeah.
Have a good weekend.